All right, so last example here, we're multiplying two polynomials. In particular, we're multiplying two trinomials, right? We had this group of three here that we're adding together, a trinomial multiplied by another three-term polynomial, okay? So as you can guess, we're simply going to distribute this, but we're going to have more multiplications to do. So every term here has to be distributed to the one after it. So there's going to be three multiplications there, and then we're going to take this and multiply this out 3 times, and then we're going to take the 5 and multiply it three times as well. So we have to distribute everything. That's just how that works. So we're going to have 9 different multiplications. So you can certainly just do this and just sort of do it horizontally and just start writing out the work if you want. Okay, so you could say, all right, that's going to be 3m to the 7th, and you can just start working the problem out. I'm going to show you one alternative to multiplying these larger polynomials out, because this might help you. So here's the method, and it's just a simple box method. So what I would do here is I'm going to rewrite this one time. I'm going to change my subtractions to adding the opposite again. So I'm going to say this is m to the 4th plus negative 2m squared plus 5, and then multiply that by 3m cubed plus m squared plus a negative 1. So all I'm going to do is I can basically use an area model or just like a box model here. So here's what you do. You just draw a box like that. And the first, basically on the left side or on the top, you can put one of the polynomials terms. So let's just say this first polynomial's terms. We can just put that, let's put that on the left side. So we're going to have 3 rows here because there's 3 terms in that first one. And I'm just going to write this on the side as m to the 4th and negative 2m squared and 5. So I just list off those terms on the side. Then on the top, we're going to put the other 3 polynomial or other 3 terms in that polynomial on the top. So we say 3m cubed, and then we have a m squared, and we have a negative 1. And I'm going to make those basically my columns. So this basically just structures your problem, because you know you're going to have to do, in this case, 9 multiplications. And if we multiply these terms out, just thinking of it as an area, you can see we have 9 boxes there. So we can multiply the 9 things here. And some people like this because it kind of organizes their 9 things that they have to multiply here really nicely. So what we do is in each box, let's say for this, you just find the area. You just multiply the things you need to multiply. So this times this is going to give us that box right there. So we look at those 2 boxes and say, well, this is 3m to the 7th. And then we say, well, what's in this box? And we look to our multiplication. We would say m to the 4th times m squared would give us this box, right? We're going to add our exponents. So that's going to give us m to the 6th. And if we go to the box on the left, m to the 4th times negative 1, well, that'd be negative 1 m to the 4th, or just negative m to the 4th. Either way works. So you get the idea here. It's more of a visual kind of way to look at these different areas, and you fill in the boxes. Okay, so this one right here would be negative 6 m to the 5th, because I'm looking at this times this to match up to give me that. And then over here in this box, I'm going to have negative 2 and m to the 4th, because when I multiply the m's, I have to add the exponents. And then over here would be positive 2m squared. So positive 2m squared. Bottom left here, we're going to have 15m to the third. Right here on the bottom middle, we're going to have 5m squared. And then on the bottom right, we have negative 5. So there it is. Everything in red, those are all my terms that are my polynomial. That's my answer, right? If I add those all together, then I have my answer. So now if I want to go ahead and write my answer, I have to combine my like terms, right? If I have any like terms, I can combine them. And what I like to do, if I do it like this, is just simply, look for your like terms right away. You can see, and I have the luxury here of color coding it, and so that'll help us kind of see the like terms. But you can see that, for example, we have the m to the fourths are like terms. So if I put that in like orange, like these right here are like terms because they're both m to the fourth. We also have these squared terms right here. 5m squared is like with 2m squared. So I'll make that like pink, right? Those are like terms. And basically when we look over this, that's all the other like terms that we have. So we basically have this combination right here. Those we could combine into one, because remember, we're taking these 9 terms and now we're adding them together. Okay, if I was doing this work off to the side, or if I didn't do this model, I would literally just have this all written out as addition. 3m to the 7th plus negative 6m to the 5th plus m to the, I'd have it all written down there. There would be 9 things that I'm adding together. So what I'm doing here is now just taking the terms and putting them underneath. So 3m to the 7th. 3m to the 7th is there, and that does not combine with anything else. Then we look to the next one. We have an m to the 6th, so that's going to be plus m to the 6th. And there's no like terms we can combine there. And then I guess I like to go just look at the exponent and just go to the exponent that's the next lowest. So we can look at m to the 5th if there's any term there. And we see that there's a negative 6m to the 5th, but there's nothing that I can combine that with. So I'm just going to write down what I have there, which is negative 6m to the 5th. And then plus the m to the 4ths. Now here we do have 2 terms that we can add together to make one m to the 4th term. So we have negative 2 and we have a negative 1. So negative 2 plus negative 1 is negative 3. Negative 3m to the 4th. So I combine that. And then next I look at the m squareds right here. There's 2 of these. Or wait, sorry. Let's go back. I forgot about the m cubed, right? So there's an m cubed right here, and there's no matching pair with that, so I can't combine that with anything else. I'm going to write that as plus 15m cubed. Then I go to my m squares right here. Since there's 2 of them, I can make that a 7, right? A 7m squared. And then the last thing I have is this minus 5. So that'll just be minus 5 at the end. So this is a long answer, I know. But that is another method to multiplying polynomials out. And this is as big of a multiplication as you're probably going to get. Is like a trinomial times a trinomial, where you have to multiply 9 different things and combine them. This is the box method, so this is more of a visual, right? So you can do this and it kind of separates things out. You don't have to do that. You can, just kind of do it out in stages like that, where you just put down the answers horizontally. You can pick whichever one you like. So that is how we multiply polynomials.